trig functions today. Okay, let's start with sine. Okay, the derivative of sine is cosine. The derivative of cosine is negative sine. Okay, so when we take the derivative of a sine function, it will give us the cosine curve. And cosine is negative sine. Just make sure you memorize that and you know which one is negative. Okay, let's take a look at the derivative of each of these functions. So the first one, I'm going to have to do a product rule. So I have like my u times v, right? So remember it's u prime v plus v prime u. Again, it doesn't really matter. You can switch those around, commutative property. So y prime. So derivative, so u prime. So derivative of x squared is going to be 2x times sine x. Then what? V prime negative cosine x times x squared. Oh, cosine, yeah. Oh my gosh, I just talked about be careful with the positive and negatives. Okay, now I'm going to do one little thing here. I want to just move the x squared to the front just because I don't want to accidentally make that a cosine of x cubed. So I'm just going to put the x squared in front, and that's really all we can do with that. Could you factor out an x? Sure. Do you need to? No. Okay. More work than you need to. Okay, what do we need to do in B? This is going to be quotient rule. All right. All right. Low D high. So we're going to take the denominator times derivative of cosine. Take the numerator times the derivative of the denominator. So it's going to be a negative cosine. Right, because the zero, or the one becomes a 0 minus derivative of sine is cosine. And we put that all over 1 minus sine x. Okay. Let's multiply out that numerator. What do we get? So that's going to be a negative sine x plus sine squared x plus cosine squared x. There are very few Pythagorean identities that you need to remember. This is one of them. What's sine squared plus cosine squared? Okay, so all of this is 1. So what do we have? We have a 1 minus sine x in the numerator. So what could we do? We can cancel out. This will cancel out one of those 1 minus sine x's. Okay, questions? Okay, really the only identities that you need are the Pythagorean triple and just like the reciprocal ones, like sine and cosecant, cosine and secant. Sine squared plus cosine squared equals 1. All right, simple harmonic motion. So this is if we have a weight, right, it's attached to a spring, it goes back and forth. So here we have a position function, 5 cosine t. We just want to find what are the velocity and acceleration at time t. So velocity is going to be, okay, now the 5 is just a coefficient. That's a constant multiple. So we don't really do anything with the 5. Just take, what's the derivative for cosine? Negative sine. So negative 5 sine t. Why would the 5 go away? So if you were to do the derivative, let's say it was 5x squared, do we get rid of the 5? No. 5 just gets multiplied to the derivative of 2x. Doesn't go anywhere. It just gets multiplied to the derivative. Now, could you do the product rule? Like, you could do 5 times cosine t, but that's way too much work. Because what's going to end up happening when you do derivative of 5? It's going to be 0, so it's going to just, like, make that other term go away. Now, how about acceleration? Okay, again, nothing happens with the negative 5. It's still there. Now we just have to do the derivative for sine, which is cosine. And it just says at any time, so we don't have to plug anything in. Good? All right, now that we know sine and cosine, we can basically figure out all the other formulas. So let's look at tangent x. How can you rewrite tangent of x? Sine over cosine. And let's see. Of course, you can see it. Pretend like you can't see it. Okay, so we're going to take the denominator times derivative of the numerator. That's going to be cosine minus numerator times, what's the derivative of cosine? Negative sine. All over cosine squared. What do we end up with? Well, we get cosine squared plus sine squared. So that turns into a 1 again. So 1 over cosine squared is the same as secant squared. All right, I am going to tell you, you need to memorize these two. You don't need to memorize the bottom two. They might show up in a homework assignment here or there, but generally it's just sine, cosine, tangent. Derivative of tangent is secant. Derivative of secant is secant tangent. The other two just don't really show up much.
If you just like play around with the algebra, we'll eventually get those.
Yeah.
Yeah.
Well, think about how you can rewrite secant. It's 1 over cosine. How would you write cotangent? Cosine over sine, and you would do the exact same thing. Do the quotient rule,
So
and
just like faster.
yes, way faster. Okay, find an equation for the line that is tangent to the graph f of x equals tangent x over x at x equals 2. So we're going to have to use our graphing calculator because x equals 2 is not a special angle. It's not like pi over 4 or something. So what do we need in order to write a tangent, a point, and a slope? Right? What's up?
Is there a way on the I think you talked about this earlier.
Yeah,
Is there a
what's
way
up?
to make color with this? We have a calculator we use that on derivative.
We can.
I just
But I want to practice. Let's practice quotient rule. We have to find the derivative. And then we're going to plug in 2 to the function and plug in 2 to the derivative. And then, yes, I'll show you on your calculator. Let me see if I have it. All right. So low d high. So denominator times derivative of tangent is secant squared minus the numerator times the derivative of the denominator. That's just going to be times 1.
Make it look easy.
Would you,
Just like
am I going too fast?
no.
Oh, okay. Just, I mean, just doing the quotient rule. Memorize it. Okay, now, there's really nothing that we could do to simplify that. So we're going to just plug in 2. So, oh, make sure your calculators are in radians. And then, Alec, yeah, you should be able to plug this into the graph and also figure it out. So if you had it in your graph and you put in tangent of x over x, yeah, but remember, we're just finding the derivative at a point. So I could just go to the menu, analyze graph, dy dx, type in 2, and I get 3.433. Of course, if you're doing it in this part, right, you would just type it all in here to what's that? Yeah. Yep. You could do that too. I'm just going to type it in so that we can just confirm that we did the derivative correctly here. 3.433. Always 3 decimals. Okay, now what else do we need? We need f of 2. Now the nice thing is, also, this is not a really complicated function, but if I already have it here, do you know how do we find a value? Trace. And we can just type in 2. Oh. Did that? Oh, here. Negative 1.092. So we. So my tangent is good. Okay, last example. We want to find the second derivative of secant x. So we are going to start with the first derivative. You can just look. What is it? Secant tangent. So secant x, tangent x. Now when I do the second derivative, we're going to do a u times v. So derivative of secant tangent, times, now we're going to keep v, so that's tangent, plus, now we do the derivative of tangent, which is secant squared, times, keep secant x. Okay. So what do we have? Secant x tangent squared plus secant cubed.